Welcome to the discussions and thank you for always joining us. This is KCSE 2003 paper 1 number 18, a question on statistics 2. And the question we have reads, the masses of 40 babies in a certain clinic were recorded as follows. We have the mass in kilograms that represent our classes and the number of babies that stand for the frequency. Calculate part A, the interquartile range of the data, and B, the standard deviation of the data using 3.45 as the assumed mean. We are going to begin by first modifying the table so that we can be able to get the interquartile range and the standard deviation at the same time. So we are going to begin with the mass, and the mass ranges from the first one, which is 1.0 to 1.9. We have 2.0 to 2.9. We have 3.0 to 3.9. We have 4.0 to 4.9. We have 5.0 to 5.9. And lastly, we have 6.0 to 6.9. Once we have that, we can now pick the frequency straight. The frequency we have is 6. The second one is 14. The third one is 10. We have 7. We have 2 and 1. From there, we can get the cumulative frequency, which is going to assist us identify the quartiles. We start with the first frequency, which is 6. Then 6 plus 14, you get 20. 20 plus 10, you get 30. 30 plus 7, you get 37. 37 plus 2, you get 39. And 39 plus 1, you get 40. Once we have done that, we can now get the midpoints again. The midpoint is 1 plus 1.9. You divide by 2. This one will give us 1.45. Then 2 plus 2.9 divided by 2, you get 2.45. Then next we have between 3 and 3.9, we add the 2. Then divide by 2, you get 3.45. Then next we have 4 plus 4.9, divide by 2, you get 4.45. Next we are going to have 5.45. And lastly, 6 plus 6.9 divided by 2, you get 6.45. Once we have the midpoints, we can get the deviations, that is t, by taking the midpoints minus the assumed mean. And the assumed mean in this case is 3.45. And therefore, if you take x, which is 1.45, minus 3.45, you get negative 2. If you take 2.45 minus 3.45, you get negative 1. Next is 3.45 minus 3.45, you get 0. 4.45 minus 3.45, you get 1. 5.45 minus 3.45, which is the assumed mean, you get 2. And next, 6.45 minus the assumed mean, you get 3. We move and get the ft by taking t times frequency. So 6 times negative 2, you get negative 12. Negative 1 times 14, you get negative 14. Then 0 times 10, you get 0. 1 times 7, you get 7. Next, we have 1, that is 2 times 2, you get 4. And 3 times 1, you get 3. Having done that, we can sum up all the FTs. And if you add from negative 12 all the way to 3, you are going to get a sum of negative 12. Next, we are going to have ft squared. And ft squared will be given by frequency times the values of t squared. Remember, we can square t. T is negative 2. Negative 2 squared, you get 4. 4 times 6, this one will give us 24. The next t is negative 1. Negative 1 squared is 1. Times 14, you get 14. The next is 0. We have The next one is 1 squared times 7. You get 7. The next t squared is 2. 2 squared is 4. 4 times 2 you get 8. And lastly we are going to have t, which is 3. 3 squared you get 9. 9 times 1, this one will give us 9. And the summation of ft squared will be 62. Once we have modified the table as follows, we can as well get the total of the frequency, and the total of the frequency will be equal to 40. From there now we can get the lower quartile, the upper quartile, then subtract the 2 to get the interquartile range. So the first part of this question, we need the lower quartile, which is denoted by Q1. And to get where the lower quartile lies, it is usually a quarter of the total, which is 40, and that gives us 10. So if you look at the cumulative frequency, our lower quartile is going to lie in this class here. And therefore, we are going to use the formula. Q1 will be given by lower limit in the lower quartile plus a quarter of n minus c divided by f times I, which is the class interval. Now to get the lower limit, remember all the values are written correct to 1 decimal place, and therefore the least error in this case will be equal to 0.1. The error that affects a measurement is absolute error, which is half of the least error, which is 0.1, and this one is going to give us 0.05. So for us to get the lower limit in the lower quartile, we take 2 minus 0.05, giving us the lower limit of 1.95 plus a quarter of n will give us 10 because n is 40, so a quarter of 40 is 10, minus cumulative frequency before the lower quartile class, which is 6, divided by f, which is the frequency in that class, which is 14. We multiply by the class interval of 1, because from 1 to 2, or 1.9 to 2.9 is 1. This one is going to give us 1.95 plus, remember 10 minus 6 is 4, so we are going to have 4 over 14 times 1, and this one is going to give us an answer equivalent to 1.95 plus 0.2857, translating to a figure equivalent to 2.2357. That is the lower quartile. We can now move down and get the upper quartile. Let us have the upper quartile. Upper quartile is noted as Q3, and to get where it lies, it is going to be 3/4 of the total, which is 40, and 3/4 of 40 will give us 30. So that is where we are going to pick our upper quartile. So this is our Q1. 30 is exactly here. This is where we are going to pick our upper quartile. And to get the upper quartile Q3, we use the formula, the lower limit in the upper quartile class plus 3/4 of n minus c divided by f, you multiply by I, which is the class interval. To get the lower limit, you simply take the lower number, which is 3, you minus 0.05, which is the least, the absolute error when taking the measurements. That one will give us 2.95. Here we have 2.95 plus 3/4 of n will give us 30 minus c, which is the cumulative frequency above this class, which is 20, divided by the frequency in this class, which is 10. We multiply by the class interval, which is 1. So we are going to have 2.95 plus 10, that is 30 minus 20 is 10. 10 times 1 will give us 10 divided by 10, which is 1. And the answer here is going to be 3.95. From here now we can get the interquartile range. To get the interquartile range, we simply take the upper quartile Q3 minus Q1. The upper quartile is 3.95 minus the lower quartile, which is 2.2357, and this translates to a value equivalent to 1.7143 as the answer to the first part of the question. Remember to subscribe and also help us to share the link. We are now going to move to part B, where we are supposed to get the standard deviation of the data. B, to get the standard deviation, is going to be given by taking the square root of the summation of ft squared divided by the summation of frequency. Then we minus the mean of t, which is given by, we minus the mean of t squared, which is given by ft. You divide by summation of fu square. This is going to give us 62 divided by 40. 62 is summation of ft squared, then minus the summation of ft is negative 12. We divide by 40, then this one is going to be squared. So if you take 62 divided by 40, you get 1.55 minus negative 12 over 40, then squared, you'll get 0.09. This one is going to be equal to the square root. If you subtract the 2, we are going to find the square root of 1.46, and the square root of 1.46 will give us 1.2083 as the answer to this particular question. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.